Okie dokie, so we are on learning intention number 8, aim number 8, lesson number 8, whatever you want to call it. Welcome to this episode on how do we pass our Common Core Algebra class / regions, right? Alright, so we're going to be simplifying radicals today. Okay, so what is a radical? Nothing more than in this case, for basic one will be a square root, the square root symbol, like this. Look, that, like radical 9, okay, radical 30, radical this, that's what we call them, radicals, okay? So let's start with this. So radicand is the number inside the radical symbol. The simplest form is that you shouldn't have any radicals in the denominator. We're not going to be facing that issue today, but we will in the future. Okay, so simplify usually means to factor the radicand until one of the factors is a perfect square. What? Easy. I'll explain to you when we do the problems. Alright, perfect squares. The normal, usual perfect squares are 1 square, 2 square. Okay, in other words, it's 1, 4, 9, 16, 25, 36, 49, 64, 81, okay, 81, 100. In other words, if you know how to count to 10, you know your perfect squares. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 square is 1, 2 square is 2 times 2, 4. 3 square is 3 times 3, 9. 4 square is 4 times 4, 16. 5 square is 5 times 5, 25. 6 square is 6 times 6, 36. 7 square is 7 times 7, 8 times 8, 9 times 9, 10 times 10. 11 times 11 is 121. 12 times 12 is 144, and so on and so forth. Okay, so now we're going to take a look at square root. The square root is nothing more than the inverse of squaring a number. If, for example, you square 3, you get 9. If you take the square root of 9, you get 3. The square root of 9 is 3 because 3 times 3 is 9. Okay, get it? Okay, now let us move on to this. Okay, so I just got a text. Now let's see. The square root of 9 is 3 because 3 times 3 is 9. The square root of 81 is 9 because 9 times 9 is 81. The square root of 121 is 11 because 11 times 11 is 121. Now, how do I simplify radicals? Well, let's take a look at this example. Radical 75. The first thing that we need to do is we need to find the factors of 175. I'm sorry, of 75. I'm going to use my calculator. Now, I don't need to use my calculator, but I will use it anyways. So, for example, what I usually do is I take the number that is given to me and I start dividing it by perfect squares. You know, 1, 4, 9, 25, 36, 49, and all that. So I'm going to divide by 4. I get nothing. I need to get a nice number. Divided by 9. Nothing. Divided by 16. 4. Nothing. Divided by 25. Look, I got 3. Okay, so that means that 25 and 3 are factors of 75. So that's exactly what I'm going to do. Now it says how to proceed. I'm not going to be giving the written explanation because I'm already giving the verbal explanation. Okay, you need to find the 2 factors of 75. One, which is the largest perfect square. In this case, we could write that square root of 75 is equal to the square root of 25 times 3. Okay. Let me see now. Okay, so I'm getting text. So I need to basically, I'm gonna answer the text, but let's see what's up. Alright. So the square root of 25. Now, how do I know this is the largest perfect square? Well, because the other number is a 3. 3 cannot be simplified anymore. 3 is an irrational number. So let's see now. What is the square root of 25? 5. What is the square root of 3? Well, radical 3, as we're gonna start calling them, is just radical 3. If 3 could be simplified even more, then I would simplify it, but 3 is a prime number. Only 3 times 1 is 3. Then that's it. You don't have anything else. So then our final answer, simplified form, is 5 radical 3, or 5 times the square root of 3. And that's how it goes. Let us try our next example. Okay? So let's see. Radical 50. Once again, you start dividing by perfect squares. 4, 9, 16. I don't divide by 1 because I'm always going to end up with radical 50, because anything divided by 1 is itself. So I know that radical 50 is equal to radical 25 times radical 2. Radical 25, the square root of 25 is 5. And radical 2 is an irrational number that cannot be simplified anymore. It cannot be broken down anymore. That's basically what I mean. So this is your final answer. All right, let us try something else. Let's try this. So some of these were questions that you had on your test, and hopefully you were able to answer. Now this is not radical 2, sorry. It's supposed to be k radical 5. That's what the answer was supposed to be. So let's see now. When radical 20 is written in simplest radical form, the result is k radical 5. Find the value of k. Well, all we have to do is simplify radical 20. Radical 20 is the same thing as radical 4 times radical 5. Remember, one of them has to have a perfect square root. If it doesn't, then you have not simplified anything. And the square root of 4 is 2, and 5 is a prime number. A prime number is a number that can only be divided by 2 different numbers, itself and 1. And 5 anyway is irrational. So 5 cannot be broken down anymore, so it stays as 5. So the answer is 2 radical 5. Express radical 72 in simplest radical form. Okay, here we go. I'm gonna show you something very, very, very interesting. Look. So you have radical 72. Radical 72, I'm gonna start dividing by perfect square. So I already divided by 4, and I got 18. That doesn't mean that I'm gonna use 18 and 4 as my, sorry, right here. That doesn't mean that I'm gonna use 4 and 18. Square root of 4 is 2, and that's it. No. Keep on trying until you find the largest perfect square. So for example, 72 divided by 9 is 8. 9 is a perfect square because square root of 9 is 3. But then again, let's continue because you might be surprised. By 16? No. How about by 32? No, not by 32, by 16, 25, right? After 16 is 25? Nope. And after 25, we have 36. Boom, look, 36 and 2. 2 cannot be simplified anymore. And 36 is a perfect square. So right there, I understood that I have found my 2 factors of 72. So radical 72 is equal to radical 36 times radical 2. Now the square root of 36 is 6, and then radical 2 cannot be broken down, so that is the answer. See that? Okay, the next one. The expression radical 121 can be written in simplest radical form is, well, I'm going to tell you right now, the square root of 121 is 11. Okay? Now, can you write this in simplest radical form? I wouldn't say so, but if you want to, you could always write 11 radical 1. But anyway, the square root of 1 is 1, so no, you cannot do it. So anyway, the square root of 121 is 11, and that's it. Okay. What is radical 27 expressed in simplest form? So then again, you start dividing by the perfect squares. I already explained to you what the perfect squares were. So anyway, why am I so serious? Oh, look, I caught you. Sorry. Okay, let us get back over here. So radical 27 is radical 9 times radical 3. Then you explain that the square root of 9, you can even write it down. The square root of 9 is 3. And then radical 3 cannot be broken down anymore, so it stays at radical 3. Express radical 8 in simplest form. 8 can be written as radical 4 times radical 2. Square root of 4 is 2, and then radical 2 cannot be broken down anymore, so it stays like that. Radical 32, the one that killed everybody on the test. Radical 32. 32 is 8 times 4. I understand. But continue dividing by perfect squares until you figure out that you have a perfect square and the other number cannot be broken down. Like for example, 16 and 2. Radical 16 times radical 2 is radical 32. And when you simplify, square root of 16 is 4. And radical 2 cannot be broken down anymore. And that is the end of simplifying radicals for now. See, that wasn't that difficult. Now please make sure you pay attention, make sure you write down, make sure you take notes, make sure you do. Oh, I caught you again. Alright, so see you on the next episode of How Do We Pass Our Common Core Algebra Class and Regions. Bye bye.